start with saying that this is another video that has quite a bit to it, and there are a lot of examples. So I'm going to go a little bit quick, but they're pretty easy because they kind of build on things we've already done. So it's not like it's a whole lot of new information, just kind of little bits and pieces here and there. So we're going to solve radical equations and then also graph square root functions as well. Let's start with solving radical equations. So things that you need to know. One is that you want to isolate the radical on one side of the equation. It'll make things much easier. You want to use inverses to get rid of the radical. And then anytime that the index is even, you have to check your answer because it could result in giving you a negative under the square root or fourth root, and you can't actually have that as a solution. So let's go ahead and, oops, I didn't mean to have that in there twice. Let's go ahead and solve some of these and see how they work. Well, the first thing that I would do is I would rewrite this 1/2 as a square root. So square root of x plus 2 and then plus 4 equals 7. And now we just solve it like a regular equation. We isolate our radical, so we get the square root of x plus 2 equals 3. To get rid of our square root, we raise both sides to the second power, so we square our function. Those cancel, or those are opposites, inverses, they undo one another. And 3 squared is 9, subtract 2 to get x equals 7. Now you always have to check, always, when the index is even, and remember your index is the number here, which is a little 2, we just don't put it there. And I'm going to put it back in the original, so 7 plus 2 to the 1/2 plus 4, and I want to know if that equals 7. 7 plus 2 is 9. We're raising that to the 1/2 power, and the 1/2 is the square root of 9. Square root of 9 is 3, and we're adding 4 to it, and it does equal 7, so we know that this is actually our answer. Next example, now this one we have 2 square roots happening on the same side. The easiest route, instead of squaring this right off the bat, it's going to add so much to it. It's just a whole lot of crazy. Instead, what you want to do is move an entire square root to the other side of the equal sign. So I'm going to move this by just changing this to a plus, and I'm going to do it on both sides of the equation. And so what happens is we get a square root of 1 minus 9n equals the square root of -1 minus 11n. And now what happens here is we can actually square both sides of our equation. And when we do that, we get rid of our square root completely, which is really nice. So our square and square root undo each other on the right and on the left, leaving us with 1 minus 9n equals -1 minus 11n. I'm going to move the larger over here. Again, it doesn't matter when you're solving equations where you move your variable to. It doesn't make any bit of a difference. It's whatever you're more comfortable with. So we get 1 plus 2n equals -1. Subtract 1 from both sides of your equation to get 2n equals -2. Divide by 2, and you will get that n is equal to a -1. And then before you circle it, make sure that you actually check that answer because our index was even. And so come over here and check it. So we're doing a square root of 1 minus 9 times -1 minus the square root of -1 minus 11 times -1. And we want to know if that is equal to 0. So under here we have 1 plus 9 minus the square root of -1 plus 11. We get the square root of 10 minus the square root of 10, and those are the same thing, and that is 0, and we're good. So we can actually go back and circle this as an answer. Our next example, again, isolate your square root, already good to go, and then we're going to square both sides. So take your left side and square it. Take your right side and square it. And what happens is on the left, we get those two undo one another, leaving you with -20 plus 9r. But over here, we get r squared. Now we have an r and an r squared, which means we have to factor. So what has to happen is we want positive r squared, so I'm going to subtract 9r to move it over here, so we get -20 equals r squared minus 9r. Then I'm going to add 20 to both sides of our equation to get r squared minus 9r plus 20, and this is a 0 now over here. And to factor it, we have r minus 4 times r minus 5. And to solve from here, what we do is set each factor equal to 0. So r minus 4 equals 0, and r minus 5 equals 0. So we would get r is 4 and r is 5. And then we have to go back and check because, again, it was square root, so you have to check your answers. So let me go ahead and get rid of all of that over there. Let me get a little bigger eraser. So get rid of this and check. And now you have to check both of them because it may be that only one works, it may be that they both work, or maybe neither of them do. So you have to check. So under our square root, we're looking for negative 20 plus 9 times 4, and is that equal to 4? So this gives you the square root of negative 20 plus 36, which is the square root of 16, which is 4, and that is equal to 4, so that one works. And then for our next one, we're plugging in 5, and again, you want to go with your original equation, so the square root of negative 20 plus 9 times 5 this time, so plus 9 times 5, and we want to know, does that equal 5? And so we get the square root of negative 20 plus 45, which is the square root of 25, which is 5, and we get the same thing on both sides. So this one actually has two solutions to it, which is a little bit different from what we're used to. So just remember, anytime that you have a square in addition to, so a square and a variable that's not squared, you have to factor. Next example, now this one has a 1/3, which remember is the same as the cubed root of the number, or number and variable in this case. Subtract 3 from both sides to give you the cubed root of 4y equals 2. We will cube both sides of our equation to undo our cubed root on the left. So the cube and cube root undo one another, leaving you with 4y equals 8. Divide by 4, divide by 4, and you get y equals 2. And we don't need to check, so no check, because index is odd. So we don't need to check it because we can have a negative under an odd index, it's okay. And a fifth example, just to show you quickly one that where a solution does not work, I'm going to rewrite this, x plus 2 plus 8 equals 6. Start with subtracting 8 from both sides of your equation to get the square root of x plus 2 equals negative 2. Well, this is not possible. You can't take a square root. So you can't take a square root to get a negative number. It doesn't work. And so because of that right there, you don't even have to go any further. You can just say that there is no solution. Now you could go further and then you would just check your answer and it would turn out that it doesn't actually work. So that is an option, but you don't have to if you see that all you have here is the square root and a negative on the right hand side. Now that we've solved them, let's go with graphing. And the graphing is really easy because it's just kind of half a parabola, and we do the same thing that we did with our transformations before. So this is called a parent function, meaning nothing is happening to it. It starts at 0, 0, it curves up, and it's going to look like half a parabola, but on its side. So it's going this way. Now a couple of things happen with our transformation. So this number out here, it's going to make the graph go up faster or slower, depending on is it a whole number. So faster would be something like 2, where slower would be something like 1/2. Okay, so that would be a slower function. If it is negative, instead of, so this number out here is negative, instead of going up, it's going to come down like this. So it'll be reflected that way. Now this number in here, your h, remember that's your left or right, so change your h. So that will shift your starting point from 0, 0 to something else. And then if x is negative, so this part right here, if this is negative, it flips horizontally. So instead of opening up and curving that way, what it does is it goes this way and curves like that. And so the negative under here flips it horizontally, where the negative here flips it vertically. And then your last thing is your starting point. So your k here, it's going to shift it up or down. And remember, it's keep the k. So change the h, keep the k. And we do have some flips that can happen. So let's work on some graphs and see how these work, and talk about first, our x-intercepts and y-intercepts. X-intercept, you set the function equal to 0 and solve, and your y-intercept, you plug in 0. So here's your first one. This is your h, this is your k. So your starting point, change the h, keep the k. -2, 3. So -2, 1, 2, 3. Now this is positive out here, the x is positive out here, so this is just going to curve like that. And you'll notice that there's no way for this thing to cross the x-axis, so we don't even have to do any work for that. We just say that there isn't one. Now when it comes to the y-intercept, you plug in 0, so we get the square root of 0 plus 2, and then plus 3, which is just the square root of 2 plus 3. So as a coordinate point, we plugged in 0 for x, and we got out 3 plus the square root of 2 for y. And that's just a standard form of writing that answer instead of having the square root first. Now your domain is your x values, so look at what x values are being used. We're starting at -2 and we're going all the way out to the right. So to put it in set building notation, we say x such that x is greater than or equal to a -2. And then in your interval, it starts at -2 and it goes off until infinity. Now your range is your y values. Well, your lowest y value here is 3. So we're going to say f of x such that f of x is greater than or equal to 3. And then that would mean that it's starting at 3 and it goes off until infinity for range as well. All right, now let's look at some that are going to shift it upside down, or maybe upside down and backwards. So this example here, this negative on the outside means it's going to go this way now. X here is positive, so it keeps it going that way. So this -1 becomes a +1, and this stays as a -2. So 1, -2. And it curves downward, and it just, that -2 in front just means it's going to go a little bit faster than normal, but you don't have to do much with it. X-intercept, well, since it's curving downward, it's never going to cross the x-axis. And then look at your y. It's starting over here and going that way. It's never going to cross your y-axis either, so no work for either of those. Now your domain is x such that x is, here's your 1, and it's using all the values over here, so greater than or equal to 1, which would be 1 to infinity. And then for your range, the lowest or the first value we use is -2. So we'll put g of x such that g of x is, and this time it's going downward, so it's actually less than or equal to a -2. So what that would mean is it's starting at a negative infinity because -2 is the highest number it can possibly be. Okay, now we're going to look at one that's going to flip it the other direction. And this is our last example. So what I want you to do anytime that you see this -x, I want you to first rewrite it and make it -x plus 3, because the 3 is positive. From here, what I want you to do is take the negative out like this and write it as x minus 3. The reason is because this means it's going to flip in that direction. And this is now your h. So we have 3, 0 as our starting point here. And it's going to go that way. Well, 3, 0 is your x-intercept. So now we're going to curve up this way and go outward. What is your y-intercept? Well, you get square root of 3 minus 0, which is just the square root of 3. So we put in 0 for x, and we got out the square root of 3 for y. Domain is your starting point, so x such that x is, and now since it's going to the left, this is less than or equal to 3, which would mean that is negative infinity stopping at 3. And then for your range, it's going from, so h of x, and it's going upward for y values, so greater than or equal to 0, which would mean 0 until a positive infinity because we're using positive y values.